In section 2.5, we're going to cover two kind of non-related topics, but that's the way your book has organized it. The first one is looking at geometry applications, or ways that we can use linear equations to solve problems of geometry. So we first need to review some formulas that might be familiar to you from other classes. If not, we'll go through them in enough detail that I think you'll be okay. The first one we're looking at refer to rectangles. So I'm going to draw a couple of rectangles here. And how we figure out the area and the perimeter of a rectangle. So if we had a rectangle here that measured 2 units by 4 units, we would find its area by figuring out how many units it took to cover up the whole rectangle, or a total of 8 units. So the way that I can do the shortcut is to take 2 and multiply it by 4. So my base formula for area of a rectangle is that you take the width and the length and you multiply the two together. If I want to find out the perimeter of this same rectangle, perimeter is the distance around the rectangle as I'm traveling around the rectangle. So I would add the length of this side and the length of this side and the length of this side and the length of this side together to get that total perimeter. Or in other words, 4 plus 2 plus 4 plus 2. The way we do the equation for that is that we say the perimeter is equal to 2 of the lengths plus 2 of the widths. Looking at area and perimeter of a triangle, our triangle I'm going to start with a triangle here that I want you to notice is really just half of the rectangle that we were looking at up at the top. And since it's half of the rectangle, that means it's going to have half of its area. We use different letters for some reason. I was not around when they named these sides. But in the case of a triangle, they call one of these edges its base and one of these edges its height. So when you're finding the area of a triangle, you multiply its base times its height, just like we did the length times the width, but we only want half of it, because base times height would give us the area of this whole rectangle, and we only want to know the area of half of that rectangle. To figure out the perimeter, we're adding the sides, just like we did with the rectangle, and we're just going to call them side 1, side 2, and side 3. And you take those 4 sides, or 3 sides, sorry, and add them together, and that gives you your perimeter. The last shape that we're going to look at are area and circumference of a circle. Circumference is just the circle word for perimeter. And again, I don't have any reason for you why they decided that the circle had to have its own name for the same thing that we've measured in our other shapes, but they did. So if you see circumference, they're talking about the distance around the outside of the circle. So we'll draw a couple of circles on here. When we're figuring out the area of our circle, what we want to know is how many squares would it take to cover up this circle. So if I use my radius, which is the measure from the edge of the circle to the center, from any point on the edge into the center, and I make them into boxes, I hope that you can see that it takes something less than 4 squares to cover up this circle, because we have all this leftover material over here. So it takes 3 and something, 3 and a little bit more, to cover up this circle. That number, that 3 and a little bit more, the Greeks figured out a long time ago that it was true for all circles, so they decided to give it its own name. Their letter pi from their alphabet, made like that. And pi is the value that's approximately 3.14 and then has a bunch of other digits. We're going to stick with 3.14 for our purposes. So the number of squares or boxes that it takes to cover up this circle is 3 whole circles plus a little bit more, because these corners that we cut off, if we stuck them together, would almost make a full square of their own. So the way that we write this is to take whatever our area is and say that we're going to have to take the radius, turn it into a square, so it's a radius this way and a radius this way, and then we need pi of these, 3.14 of these radius squares, in order to cover up our circle. Those smart Greeks also figured out a relationship between the radius and the circumference. They figured out if you take both of the radii, or we call that distance the diameter, 2 radii equal a diameter. If you take that diameter and you use it, that length, to trace around the outside of your circle, that you can go 3 and a little bit more, this may not be real even, diameters to get around your circle. So it's that same relationship of pi again, that 3 and a little bit more. So the formula that we're going to use for circumference is either that you need 3 and a little bit more, or pi, diameters to make it around the edge of a circle. If the information you're given in the problem isn't the diameter, if it's the radius, you could also take 2 radii and multiply it by pi, and that would tell you the distance around the outside of your circle.